In this video, we are checking out exam-style questions using trigonometry. If you haven't practiced enough trigonometry yet, check out my introduction explanation video as well as the application questions that we've already done in this series. Alright, let's have a look at this exam-style question. We have got a cuboid here and we want to find the angle of the diagonal AG. And oops, I just realized my cats must have jumped on my keyboards here. I don't know where all of these letters are. A, B, C, D, maybe E, F, G, H. Yeah, that makes a lot of sense. So what we actually want to find here is the diagonal from A all the way till the other end, G. And we want to find the angle at the bottom here, the angle with the ground. So I'm actually going to remove all of those letters again. Yeah, just so that we don't get confused. It's getting too messy. We do want to start here and end here, so keep that in mind. So how can we do that? Well, first of all, the first thing we would do is we would connect those two dots, right? There we go. So this is what we want to find. And we already know that the angle is kind of like this with the ground. So if we now want to find a right angle triangle, well, we definitely need to find the angle that we're looking at, which is on the ground. And we can kind of see that here we can form a right angle triangle. Now, this requires a little bit of practice to see this. But of course, we have a right angle here because in a cuboid, the lines going up and the ground are on a right angle. So here we have 5 been given. That's very nice. We don't actually have the diagonal here. What else can we do? Well, we could possibly find the side here at the bottom. Now, we only have the opposite side here, so we can't actually do anything quite yet. We need to find some more things first. We've said already that if we want to find the angle here, we need to have either the diagonal or we need to have the kind of like the bottom diagonal, the diagonal on the base. If you guys want to, there's 2 options. You guys can have a look at the bottom of the cuboid. This also forms a right angle triangle where the right angle sits here in the corner. That is because we are on the ground and we have a rectangle as the base. So we can calculate that line at the bottom using that triangle at the bottom. So let's draw this blue triangle over here. We have a right angle triangle with 7 and 10. And what we want to know is this kind of diagonal over here. Well, we can use Pythagoras theorem over here to calculate these. So we have a squared plus b squared is equal to c squared. Just remember that c squared is always the longest side, which is opposite the right angle, the hypotenuse. For the other two, it doesn't really matter which order we do them in. So let's substitute in our values. We get 7 squared plus 10 squared is c squared. So we get 49 plus 100 is c squared. 149 is c squared. And how do you guys find c here? Well, we need to get rid of the squared by doing the opposite. And the opposite of squaring is square root. We only worry about a positive number here, of course, yeah, because we know that these measurements are positive numbers. So let's put that into the calculator and find what number we get. So we have 149 square rooted. There we go. And of course, we need to press the SD button in order to change it to 12.2, the decimal. Let's put that in as 12.2. So now we know that the diagonal in the bottom is 12.2 centimeters. And we said now we can use this information to figure out the angle that we wanted. So we're going back to the red triangle, this one over here, and we can draw it on the side with the right angle over here. What we know is that the opposite side here of the angle that we're interested in is 5. Yeah, so this was the angle here in the corner, which is this one. That's the angle that we're interested in. And we need to have the bottom as 12.2. That's what we just figured out from the blue. Now we have a triangle and we want to find the angle. So let's mark our parts in the diagram. H, O, and A. We have A and we have O. So this is going to be CAH. Sorry, my bad. This is TOA, of course, TOA. And what do? We cover the one that we want to find. Well, we want to find the angle, so we're going to have to cover the tan part here. And remember, if you guys are finding the angle, we need to use tan inverse for our question. And then we follow the pyramid, right, or the triangle, O divided by A. So we're going to get, what happened to my blue pen, by the way? I shouldn't have changed that color, right? Let's get back to blue. So we're going to get O, which is 5, divided by A, which is 12.2. And let's chuck that into the calculator and see what we get. This is a very calculator-heavy assessment, right? Is this going to work for me? Thank you very much. So we have 5 divided by 12.2. Let's chuck that in. And sorry, you guys can't really see, but it's 22.2. Let's write that down, 22.2 degrees. Okay, this is a very, very popular question to be using 3D objects in order for us to use trigonometry. Right angle triangles, either for Pythagoras theorem or trigonometry rules, is one of the standard questions that you're most likely going to be encountering. If you need more of these questions, make sure you join the Discord. The link is in the description. I have lots of courses and lots of resource hubs set up so you guys can practice a lot of these questions before an exam. If you need extra support with your studying, join our free Discord community where you can ask questions, get help, and even request me directly for one-on-one tutoring. Inside the Discord, you'll also find a full resource hub with worksheets, study guides across different subjects, and I highly recommend checking out my website where I've put together full courses organized in order so you won't miss any of the topics. You'll find both links to the Discord and the full courses right below in the description. We have a rhombus with perimeter 100 centimeters. The length BD is 20 centimeters. First, find the interior angle X. Then use this information to find the remaining interior angles. Okay, so let's start by having a look what the question tells us. It tells us that the perimeter is 100. And this is something that I see a lot of my students struggle with, is they write down what this is, but they don't know where to go from there. Because we don't actually need to use that information. We actually need to backtrack and see how we found the perimeter. That will help us. So how do we normally find a perimeter? The perimeter is adding all the sides together. Now we know this is a rhombus. So a rhombus has all of the sides at the same length. So we have 4 times a side length. So 4 times x. So let's not call it x. That was a bad one. Let's say y. Yeah, so we have y, 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 and y. So 4y is actually 100. So you guys can divide this by 4 to find y, which is 25. That means that each side length of this shape is actually 25. Now, why do we need this? Well, we want to find something with an angle here, and it's marked in blue. In order to find an angle, right, even though the angle here is clearly wanting you to look at this triangle here, we cannot use this triangle using trigonometry. There's ways to use trigonometry for non-right angle triangles, but this is not the scope of what we're doing today. So in order to use sine, cosine, and tan, we need to have a right angle triangle. And lucky for you guys, they actually gave you guys a right angle triangle here, which is this part over here. And we have an angle here that we can find at the top, right over here. And in order for us to find this angle, we need another side. So what can we do here? Well, they tell you that BD is 20. So let's put that into our question over here. BD is 20. Well, if that is 20, how can we find the side? Well, that's half of it because we have a symmetric shape. So now what we have is a right angle triangle. And we have that one side is 10 and the hypotenuse is 25. and we want to find the angle over here. So how do we do that? Well, we have a look. This is our hypotenuse, this is the opposite and the adjacent. Our question has the hypotenuse and the opposite, so we're going to have to use SOH. And what are we finding? We're finding the angle, so we're going to have to cover up S. Remember, if you're finding the angle here, the angle that we're looking for, the green one, is sine inverse O over H, so 10 over 25. Let's chuck it in our calculator. We're going to get the inverse sine of 10 over 25. There we go, which is 23.6. Okay, now we found out what the angle is. Let's have a look here. Remember this angle, that is this green angle that we found here. And what did we actually want? Well, we wanted the blue angle that was shown below our little sketch. So that was that angle over there. Well, our triangle that we used here cut this angle into half. So what we actually found here was this green angle. I'll put it in green, this angle over here. But our angle that we want to, the blue one, is this whole part over here. So that is going to be double our angle. So x in this case is 2 times 23.6. So we're going to get, what is that, 47.2 degrees. I should probably write degrees for everything. There we go. Okay, now we've finished finding the interior angle x. And it says use this information to find the remaining interior angles. Well, we know it's a rhombus, so this angle that we have on the other side here will also have to be 47.2 degrees because of symmetry. So we already have 2 of our angles done. The last part for us is to find the angles, which I can let me put them in a different color. Let's do pink or orange. Pink is too much to like red. So this angle and this angle here. And again, we know that those 2 angles are the same. Now, for exam style questions, often topics overlap a bit. So here you guys have to remember that in a quadrilateral, so any shape with 4 edges, like a rhombus, we have that the interior angles add to 360 degrees. So that is all 4 angles added together give us 360. So what we can do is we can do 360, take away the 2 angles that we already got, which is 47.2. And we've got 2 of those. Let's see what we get. That's our remaining number of the remaining angle sizes. So we have 360 minus 47.2 multiplied by 2. Then we get 265.6. And because the 2 angles are the same size, we can now find what one of them is by halving that number. So we're going to do 265.6 divided by 2. So we can go in our calculator and just go answer divided by 2, which is going to be 132.8 degrees. So we found that our orange angles were 132.8 and our blue angles are 47.2 degrees. Awesome. Now this is our last exam style question for this video. Let's give this question a go. The diagram below shows a rectangle with a gray stripe through it. Lines FB and EC are parallel to each other. Angle CED, so that is given to us over here, and over here is 33 degrees. We also get that FE is 2 meters, and that is the same as ED. ED is 28 meters. Sorry, I didn't read that right. And it's asking us to find the area of the stripe. So the area of that. Now, when you guys have this question, the first thing you guys need to think about is you want to find the area you need to figure out what shape it is because each shape has its own formula for the area. It is a parallelogram here because we can see it's kind of like a shifted rectangle, right? We know that the opposite sides are parallel and the same length, so that is exactly what a parallelogram has. And we've done this in this already. It's base times height, if you guys had a look earlier on. Yeah, so base times height. So what do we actually need? We need the base. Well, the base is already given to us, right? That's 2 meters. So that's fantastic. We can write 2 for base. But now we need to find the height. How does the height work? Well, the height is always on a right angle to the base. So this is our height. So this is what we need to find. So what can we do now? Well, we have been given an angle of 33 degrees here in the corner. So if we wanted to use that, well, the 2 lines creating this angle would be these 2. And you can kind of see just by tracing the sides that create our angle, you can see where we're going to get our triangle from. Now let's draw this triangle over here in the corner. Yeah, there we go. We have a right angle triangle with an angle 33 degrees. And what do we want? We want the opposite, which is h here. We have also been given the bottom side, which is 28 meters over here. So let's use this triangle. Yeah, how do we do that? We first write hypotenuse, opposite, and adjacent. And we can see we have the adjacent. We want the opposite. So that's A and H. Sorry, guys, I'll move over a little bit. It's A and O. So we're going to get TOA, T-O-A. And we're going to find the opposite. So we're going to cross out O. So we're going to get that our opposite, which is the height for the parallelogram, is equal to T, which stands for tan. Of course, we have to do the angle multiplied by the adjacent, which is 28. So if we put this into the calculator, we're going to get tan 33 times 28, which is going to be 18.2. We're just going to round to 1 decimal place again. Yeah. Okay, now we have found what h is. Remember, we wanted to find the area, which was the base 2 multiplied by the height 18.2, which will give us 36.4. And don't forget the unit, meters squared. Awesome, that's it for us for today. Now, this is everything you need to know for sine, cosine, and tan. If you guys are keen to find out how to use them for non-right angle triangles, comment below and I'll post the link. And have a look at our playlists so that you don't miss any of the other topics that you need for your exams in your specific year.